Hello logic people, welcome back to my garage, and of course it's raining again. Today we're going to evaluate the validity, or learn how to evaluate the validity of categorical syllogisms. That's a certain kind of argument, using Carroll diagrams. Let me define what a categorical syllogism is first. A categorical syllogism is defined as a two-premise deductive argument made up entirely of categorical statements. Right? We already basically know what this means. Deductive argument, that's an argument where the author is attempting to guarantee the truth of the conclusion based on the premises. Such an argument here only has two premises. And the entire argument, premises and conclusion, made up of categorical statements. We learned about those a couple of videos ago. The other thing about a categorical syllogism is that it involves three and only three terms. In other words, sets or categories, each used exactly twice. So I'm going to write down a categorical syllogism, an example of one right here. So for example, let's see. All dogs are friendly. Okay. No hyenas are friendly. Or so I've heard. I don't know. Therefore, how should we do this? No dogs are hyenas. Okay, so let's look at this. The author is attempting to guarantee the truth of the conclusion based on the premises. If the premises are true, the conclusion follows. At least that's the attempt. That's the intention. And of course, we're going to test whether that actually works here. Three terms: dogs, friendly creatures. Yeah, maybe the universal discourse is creatures, animals maybe. Hyenas. So we have three terms. Each occur twice. Dogs, right here. Friendly animals, right here. Twice, 1, 2. Hyenas, twice. See how this is a categorical syllogism. It turns out, if you follow this kind of setup here, you wind up with only 256 kinds. All right? We're going to be learning a technique for testing the validity of such categorical syllogisms. So we have an example right here. All dogs are friendly, etc. Let's Carroll diagram this. Now, you see what I've done right away. We have three terms, so we should have 8 squares. 3 terms, right, 8 squares. Just like when we had 2 terms, 4 squares. If we have 4 terms, then of course that would be 16 squares. We're not going to get to that. You can do that on your own. All right, 3 terms. And the terms will be, let's say, D, F, and H. And we'll do it in that order. Now, each term is going to be represented by not 2 squares this time, but 4 squares. So first of all, let me number the squares. 1, 2, 3, 4, 5, 6, 7, 8. Okay. The set of dogs, let's call it right here, dogs, will be represented by regions 1, 2, 3, and 4. Right here. In other words, the dogs live here in the upper half of this diagram. Friendly animals, right here, will be represented by regions 1, 3, 5, and 7. 1, 3, 5, and 7. Okay? Oh, I should make it clear. Dogs represented by 1, 2, 3, and 4. So non-dogs will be represented by 5, 6, 7, and 8. Put that here. Non-dogs, 5, 6, 7, 8. And so non-friendly animals, right? Not friendly animals. Okay? Would be, let's see, non-F. That would be 2, 4, 6, and 8. 2, 4, 6, 8. Okay? Now you might be thinking, okay, where do the hyenas go? Well, the way Carroll set this up was to say, in a way to make this work, is that the third term here, hyenas, that's the third term we see. See the order here? The first term goes on this, the left here, takes the top half of the squares, first term. The second term takes this left-hand vertical, and then the third term takes these middle 4 squares, hyenas. And then non-hyenas would take the remaining 4 squares. See this? Not H, or non-H, and non-H right there. Okay? So let me write that down. H is represented by 3, 4, 5, and 6. Non-H would be represented by 1, 2, 7, and 8. 1, 2, 7, and 8. Okay? So I'm going to leave this for a second and look at that. So we have the categorical syllogism that we're going to be testing for validity. And we set it up this way in a Carroll diagram. Now, we haven't said anything yet in this diagram. We haven't symbolized it at all. But this is the initial setup. You've got to get that right. Otherwise, you won't be able to do an accurate Carroll diagram. All right, let's diagram this argument right here. All dogs are friendly. We're going to be using zeros because it's a universal statement, so we'll use zeros. And unlike in the past where we used just 1 0, you're going to have to use 2 zeros here because we're dealing with 8 squares. So every dog you will ever meet, it says, if you're a dog, you're going to be friendly, which means you won't be non-friendly. So we need to rule out regions 2 and 4. We have just diagrammed premise number 1. The next step is to diagram premise number 2. No hyenas are friendly. There's no overlap between the set of hyenas and the set of friendly animals. So take hyenas right here. They live, so to speak, in 3, 4, 5, and 6. You're never going to find a hyena that is friendly, it says. So you put zeros right there. The diagramming is done. That's really important to understand. When you Carroll diagram a categorical syllogism, all you do in terms of diagramming is just diagram the premises. Okay? So I'm going to write that down just right here. Diagram only the premises. Now, remember what a deductive argument tries to do. It tries to guarantee the truth of the conclusion on the basis of the premises. So what you're going to do is think about, does the symbolization here, does the diagram here make it true that no dogs are hyenas? Or does it leave the possibility open that some dogs are hyenas? So let's look at this. If no dogs were hyenas, you'd expect zeros in, let's see, dogs live in 1, 2, 3, 4. You'd expect zeros in 3 and 4, wouldn't you? You'd expect zeros there. And they are there. So those, right, these zeros here, this diagram as a whole, with a combination of these two premises diagrammed, makes it true, guarantees that the conclusion is true. You'd expect zeros to be in regions 3 and 4. They better be there to make this argument valid. In fact, they are there. Therefore, this argument is valid. That argument's valid. I'm going to leave that up for a second right there. Look at that. Now let's alter this argument just a little bit. Instead of the first premise being a universal affirmative statement, an A statement, Let's make it an E statement. Let's actually make all the statements E statements. Keep the same form. The terms are still ordered the same way. Let's just change the quantifier out here from an all to a no here, at least in the first statement. No dogs are friendly. Okay, well, the second premise is already diagrammed. Remember, it was diagrammed right here with zeros, so let's leave that there. But now let's diagram this one. It says, no dogs are friendly. Okay? So, false, but in any case, that's what this argument says. You're going to put zeros in 1 and 3. Now, we've already diagrammed the second premise here, right there. So you don't need to put another 0 there. It's like double empty. No, it's empty. So leave 1 0 there. But now we need a 0 in 1. So premise 1 is diagrammed with zeros in 1 and 3. And then the second premise, 3 and 5. So now our diagram here, only the premises, zeros in 1, 3, and 5. Now the question is, are the premises sufficient here to show that the conclusion is true? Do the premises here guarantee the truth of the conclusion? What do you think? It doesn't, does it? Premises do not guarantee the conclusion. This diagram here leaves open the possibility, right, that there are some members of region 4. Region 4. There could be something here. Could be something living here. Something that's both a dog and a hyena. So this argument then is invalid. The premises do not guarantee the conclusion. Invalid. Follow? Okay, let's do another argument, but this time I'm going to add a particular statement or two. Okay? So let's say all friendly animals are dogs. Some hyenas are friendly, therefore some hyenas are dogs. Let's diagram those premises. Okay, premise 1, all friendly animals are dogs. Friendly animals, remember, reside in 1, 3, 5, and 7. Every time, right, there is a friendly animal, if there is one, it's got to be, right, a dog. So it cannot be a non-dog. So the zeros would go in 5 and 7. Now, the second premise, we're not going to use zeros, we're going to use X's, because it's a particular statement, right? It's not a universal statement. Some hyenas are friendly. Okay, so we're talking about hyenas here. Hyenas are friendly. Let's see. Normally, you'd put an X either in 3 or 5, right? Because that's the overlap between hyenas and friendly animals, 3 and 5. But 5 has already been ruled out. So, some hyenas are friendly has to be diagrammed this way, an X in region 3. The diagramming is done. Now the next question is the argument valid? Have we guaranteed that some hyenas are dogs? Okay? This X here says at least one hyena is a dog. Isn't that what it says? At least one hyena is a dog. Okay? So, argument is valid. All right. I'm going to change it up a little bit again. Okay? I'm going to leave this here for a second. Let's do this. Let's do some dogs are not hyenas. Let's do that. No friendly animals are therefore, some dogs are not friendly. And we're talking about friendly animals. I don't need to write that down. Okay. Let me prepare the diagram. Begin the same way right here. I'm not reordering. You notice this? I'm not reordering the letters here. I could do that every single time. Make this D, H, and then F, because that's the order we see it here. But we're talking about the same subject matter, the same terms, and I don't want to rewrite this every single time, so just bear with me on that. Hopefully this makes sense. Okay, I'm going to diagram this incorrectly at the start. So just bear with me right here. I'm going to diagram this premise first. Let's see how this goes. I'm doing this to make a point. You'll see. Some dogs are not hyenas. Okay, we're talking about dogs right here. 1, 3, 2, and 4. Some are not hyenas. That means at least one dog is not a hyena. So, there is an X. There is a dog somewhere in regions 1 and 2. Now, I mentioned last time how to do this. We're going to say this. We're going to say, there is an X somewhere in regions 1 and 2, and the way we diagram this using Carroll diagrams is this way. We put an X here and an X here, and we put a line between the two saying that we're not sure where the X really is, but it's somewhere in, right? It's either in 1 or it's in 2. Because we don't know whether it's friendly yet. Okay? Now, no friendly animals are hyenas. All right. Let's see. No friendly animals are hyenas, so you're going to have zeros in 3 and 5. Okay? Does it follow that some dogs are not friendly? Okay, I'll wait for a second right here. Think about this. Does it follow? Is it guaranteed that some dogs are not friendly? It's not guaranteed. It could be the case that a dog is not friendly. It could be the case that there's a dog in region 2, but we don't know whether it's in region 1 or 2. It's not guaranteed that there's at least one dog that's not friendly. The X could actually be in 1. So this is invalid. Okay, I'll pause there for a second. Okay, I've written down a couple of categorical syllogisms to make a couple of different points. And we'll end with these. Let's look at this one. Some dogs are friendly, no hyenas are friendly, therefore some dogs are not hyenas. Now, I don't know what your intuition tells you, but we're going to use a Carroll diagram to test it. Now, I'm going to begin this one in an incorrect way. Again, bear with me. Some dogs are friendly. So, if you were diagramming this on its own, it would look like this. There's at least one dog that's friendly. So there's at least one thing that's in 1 or 3, right? We don't know whether it's 1 or 3, somewhere in there. So we're going to put X here and X here, and then have a line between the two telling us that it's straddling these categories. We're not sure which category it's actually in. Okay? All right. No hyenas are friendly. Now, if you're going to diagram that, you would put a 0 in 3 and a 0 in 5. Now, look at this. This does not make any sense. Because here you're saying, oh, there could be a dog in 3. That's what these X's mean. There could be a dog in 3. Could be in 1. Could also be in 3. But also, there's nothing in 3. So that makes no sense to say 3 is empty, but there could be something in it. You know, make up your mind about it, right? So what this means is that you always diagram. So this is a rule here. When you're diagramming categorical syllogisms, always diagram the universal premise first. Look at these two premises. That's a particular one, that's a particular premise, particular affirmative premise. It's an I statement. And this right here is an E statement. That's a universal claim. Always diagram the E first. Or it could be an A, right? But whatever the universal premise is before you do the particular one. So if you did that one first, you'd have zeros in 3 and 5. And then you knew exactly, right, where X would go. X would have to go in region 1. So that is the diagram for the premises. Do not begin with this one. So that's a rule. Does the conclusion follow, by the way? Some dogs are not coyotes. Sorry, coyotes, where did that come from? Not hyenas. Look, there is at least one dog that's not a hyena, right there, region 1. So yeah, that's valid. Cool. Let's see, let's do this last one here. Now, there are no universal premises, so we don't have to worry about the order that we diagram it in. Let me erase this right here. Okay, so some friendly animals are not dogs. Let's see, friendly animals right here, 1, 3, 5, and 7, are not dogs. So you're going to put an X here, and a line between the two. Does that follow? Like that. Some hyenas are not friendly. Okay? Hyenas, 1, 3, 4, 5, and 6, and the non-friendly animals live in 2, 4, 6, and 8. So there's at least one hyena that's not friendly. Now you're not sure where it goes. 4, 6, so you straddle these X's here. Same thing right here. You see this? Okay. So that's the diagram for the premises. You're done diagramming. Now let's interpret this. Interpret the diagram in relation to the conclusion here. Some hyenas are not dogs. Now for this to be true, you need an X in either 5 or 6. Okay? For this to be guaranteed, you need an X in either 5 or 6. It doesn't matter which one. As long as you have an X in one of these, then the conclusion follows. The conclusion is guaranteed. But let's look at this. There's a chance that there's an X in 5, and there's a chance here there's an X in 6. But 2 chances doesn't mean a guarantee. Doesn't mean a guarantee. It could turn out that the X actually is here in 7, and the X actually is here in 4. We don't know. This conclusion is not guaranteed. The argument is invalid. Okay. So this leads to another rule. Okay? A categorical syllogism is never valid. Never valid when both premises are particular. That is either I or O premises, any combination, anything. No matter how you tweak this and order the terms here. In a categorical syllogism, you're never going to have a valid argument. You need a universal claim, right? To make a broader statement, I guess you could say, a more general statement. One way I like to look at it is this. In an argument that has 2 particular premises, right, you're gonna get a diagram that looks like this, right? It's too iffy. You're like, where does the X go here? So there's iffiness here, and then there's iffiness here. If there's a universal premise, you might get a little iffiness, right, in regard to one premise, but then you get something solid, so to speak, with another. But here there's too much iffiness to guarantee a conclusion, whatever that conclusion is, given the sets involved here. Hopefully that makes sense. Do as many examples as you can. There are lots of good examples in the book. exercises, and then look at those exercises online. All right, hopefully this makes sense. Hopefully you enjoyed Carroll Diagrams. And I'll see you next time.